everybody today? Should I wait for more?
There might be more that show up late, but
Alright.
that's their thing.
Their problem. They'll deal with it. Hi everybody. You're all eating, which makes me feel a lot better because you're going to be happier by the end of this then. So yeah, I wanted to do a quick talk today on building CLIs, specifically building them in Go, because if you don't build them in Go, then I am going to cry at you, and it's going to be unfortunate for all of us. So start off really quickly. My name's Paddy. I think a lot of you know me already. For those of you that don't, hello, I'm always like this. And I just kind of want to talk to you about your CLIs today because I have some feels about these, some strong opinions. As I do, you can heckle me. You're all eating, so you won't heckle me, but if you want to, I'm Paddy Foran on Twitter, and the hashtag for this talk is my CLI is the worst and I'd rather complain about it than fix it.
That's like a whole tweet, right?
Yeah, that's kind of the point, but yes. So, I am going to be throwing a little bit of shade. How many of you are Ruby, Python, or Node.js developers primarily? A lot of you. Good. Excellent. I'm going to make you mad at me by the end of this. And how many of you, if you're writing a CLI, are going to be doing it in Node.js, Ruby, or Python, like just by default? Probably a fair few of you? Okay. I'm hoping to change your mind by the end of this. But that is not to say that I think Node.js, Ruby, or Python are bad languages. I think they're actually great, and they're great at a whole lot of things. I just think CLIs are not a thing they're great at, and we'll talk a little bit more about that. But I want to get that like ground rule established here. This isn't Python is bad, Go is good. It's just CLIs Go has some advantages that Python does not. So we're going to start with a story. 'Cause I like to start everything with stories. I'm a big fan of stories and telling them because it involves me talking. So like a really long time ago, like 4 years ago, but a long, long time ago, I worked as a developer experience engineer at a company, and that's a really fancy way of saying I was a developer evangelist, but also like built stuff, I guess. I don't know. It was a weird role. Basically, it was my job to make our product not hurt, and we sold things to developers. So a lot of my job was going around talking to developers and figuring out why things hurt. Because when things hurt, we make less money, and we like making money. So I got to go to hackathons, I got to go to conferences, I got to go out and visit customers in their office and watch them use our tools and, you know, see how that went. Spoilers, it did not always go well. And the one thing I learned that was kind of the big takeaway I got is your install process hurts. Our CLI was the main point of interaction with our service at the time. It was written in Ruby. It required Ruby 1.9.3 at a time where OS X shipped with Ruby 1.8.7 and broke if you upgraded it in lots of fun and interesting ways. So that hurt. But you think of your install process and you're like, oh yeah, download our CLI and then do it. Like that's it. Like 2 steps. You just get the CLI and then you do the thing. It's awesome. Everything's great. Your install process doesn't actually look like that. If you watch users use it, your install process means, you know, download the specific version of Ruby, Python, Node, or whatever your CLI works with. My system depends on a different version. So now we got to install a version manager for that interpreted language to figure out which version to use. So that's going to be super fun. And then we're going to go through and we're going to get the package manager that it's using because of course you got to pull in all the dependencies too. So you're going to need your npm, you're going to need your pip, you're going to need your gems. Oh crap, which version of Python or Ruby or Node, because now I've got multiple on my system, which version actually has that package manager, and when I install it, is it going the right place? And I'm so confused. I hate computers. Why did I ever choose this job? Hold on. It worked. It ran. Nobody sneezed. Nothing changed. This computer is now like this forever. It's a dedicated machine. It just runs that command because it works now. Can't explain why. Don't know what I did, but it works. Okay, now I can do the thing. Hooray, I did my job. And that's actually a best case scenario. When I go to install your CLI, here's what it looks like. Ah, crap. They wrote in something that's interpreted. How long do you think it'll take me to rewrite this in Go? Too long? Okay, I didn't want to use it that badly anyway. If I had $1 for every time I ran pip after I upgraded OS X and I got some permission denied error, or I spent 6 hours Googling to figure out what OS X changed in their latest version that makes Python modules not work anymore, I don't think I've still gotten them to work on my work machine. It's just a pain. It hurts. I lose time to this, like a lot of time. You have a question?
Yeah, how much does containerizing your CLI alleviate these problems?
Have you ever tried to run Docker on Windows or OS X?
Mm-hmm.
Okay. Older versions of OS X,
You
it's a
can even do
nightmare.
it without installing Hyper-V, but it's kind of a pain.
Yeah, it's a little bit of a hurt as well. You get all sorts of weird errors, and it's like, is the error inside of the container? Is it a Docker error, or is it an error inside the CLI, or in how the CLI interacts with Docker? It's really confusing. Actually, the last place I worked, we deployed everything in Docker containers, and our development process used to be build and run everything in Docker containers on your host. And I lost like a week to that, and before I was just like, nope, everything will be built and run inside like my computer, and then we'll put it in Docker containers, make sure it still works, and then do it.
So it's a whole set of different problems.
Yeah, you're trading like, one set of sort of different things. Same with VMs. We can do better than that. There is a way to do this that does not hurt like that. And actually, it's really not even that hard. So we're going to go back, and this is our goal, right? This is what we want to do. You want them to download the CLI, and you want to be able to do the thing. That's it. No steps in between. So what would you say if I told you you can do that? That's a thing you can have. And you can do it using a language that's easily approachable from Ruby, Python, or Node. So you don't have, it's not a huge learning curve. I'm not asking you to learn functional programming here. It's easily approachable. It's not Java. And it already has a healthy ecosystem of CLI building tools. If you'd say something like, gee, Paddy, you're the best and so handsome, then, thanks, you're pretty great yourself. But that's actually the case. I'd like to talk to you about Go today. So Go is a language with some excellent networking tools built in. It's got really great first-class HTTP libraries. It's got a robust and varied ecosystem around building your CLIs. It's got a lot of different ways you can build a CLI and a lot of different opinions on how CLIs should be built, and they all have tooling built around them. I'm somebody that likes to reinvent the wheel a lot. I'm like, hey, that variable's named wrong. Time to just rewrite the entire package. It's fine. But even I have trouble justifying writing my own CLI package because anytime I have a differing opinion, somebody's already written a package that works for me. And best of all, this is my favorite, it's got static compilation. So you can download the executable it produces, run it, and there's no interpreter, no dependencies, nothing else the user needs to install. It's literally you down a binary and you run the binary. That's it. And this is magic. And I don't think people quite realize how magic this is sometimes. So we're going to show you today. It's going to be fun. But before we do that, let's take a look at our excellent networking tools I was talking about. So let's actually just take a look. I built a simple service that shares Go proverbs, and Go proverbs are like these quotes that we share in the Go community that are pithy little aphorisms that kind of encapsulate the spirit of being a Go developer. Not necessarily a requirement or not something that we consider a hard and fast rule, but a good guideline. So I built a service for it, and this is all actually open source. You can go view that GitHub repo at your leisure. Can everyone read this text? Let's make it a little bit bigger. How's that? Is that better? Mm-hmm. All right. So this is all it takes. We're at 44 lines. This is how you make an HTTP request in Go. This is what the response is going to look like. It's going to have an ID and a value, and the value is going to have the quote key in JSON. You're going to give it a base URL for the API, an ID, which is optional, and any HTTP headers you want to add. And it's going to return that quote object and an error. And we're going to just trim off the trailing slash on the URL if it has one, add one in, so it can kind of standardize the way our base URLs are specified. If an ID is specified, we're going to add a URL string that's got the quote key set to the ID, and then we're going to encode that and add it to our URL. Everyone following so far? Mm-hmm. Awesome. and then we're going to create a new request with it. A new GET request has no body, and it's for that URL. If there's an error doing that, we're going to return the error. We're going to set our accept header to application JSON. All of the headers that we passed in, we're also going to add those. And we're going to go ahead and we're going to make a request, and that's this line here. You return the error if there is one. You close off the body when it's done because we can stream response bodies, so it's stream processing, but that defer just says no matter where you exit out of this function, we want you to close the body before it exits. We're going to read all of the data out of the body, and we're going to parse the JSON for it and return the JSON as a Go object. Everyone follow that? That is actually production-ready code, which is the interesting part of this, is that I've written code like that is in production today serving multiple requests a second, like it's getting some use. So that's actually code you can use. That's what I mean when I say we have excellent networking tools. So building a simple CLI is easy with the standard library is also another great thing. So like the standard library provides me with all the tools I need to build a CLI. Sorry. And it doesn't actually take that much code or that much time. So let's actually take a look at this because I built a simple CLI using the standard library. And main is just the function that gets run whenever the executable starts up. We're going to read an environment variable to figure out what the API URL should be. If it's not set, then we're going to print a message about it, and we're going to exit with the error code 1. And you can easily exit with any code. It accepts any integer here. We can read command line arguments. So we're defining a flag here that's the proverb flag, and you can specify the ID of the proverb to retrieve, leave empty for a random proverb. By default, it's empty, and it assigns it to this ID variable here. When we call flag.parse, it parses all of the flags that were passed in. It returns any errors, prints usage messages, stuff like that, and puts it in that ID variable. Finally, then we just call that getProverb method that we just walked through, passing in the information we just pulled out. If there's an error, then we print out the error and return with an exit code 1. Otherwise, we print out the proverb itself, and we're done. So that's actually code that can run. Let's see here. Do that, and do that. And if we do... Sorry, I'll try and stay out of the way here. We want to check out, I believe it's library 1, or sorry, standard 1. Okay, and we cd to prod standlib, and we go install. So that just built the Go binary for me. It located it in my Go path, which is a thing you don't really need to worry about. But there's a bin folder, and you'll see probstandlib is the command I just created. I'm going to actually go ahead and run that. And it lets me know proverbs URL must be set to the API endpoint to retrieve proverbs. So if I export proverbs URL equals go proverbs.paddy.io, we'll do a trailing slash just for the fun of it. With the unsafe package, there are no guarantees is one of the proverbs. Don't panic. We can ask for a specific one. We can ask for the one about errors. With the unsafe package there, oops. We actually need, I forgot, quote, or sorry, proverb. Errors are values, and no matter how many times we run this, we're still going to get the same response. So again, that's a command. That few lines of code, we can actually take a look here. that's 30 lines of code, and we got an HTTP API into a CLI. We can look just to make sure I'm not pulling a fast one on you. That's that code I just showed you. So that's what's running. So let's get rid of that. I can't type when people are watching me. Alright, so that's how easy to build it. That's how easy it is to build a command line using the standard library. But we haven't talked about error handling. Like that's obviously the easy case. Everything worked. Hooray! I like when things work. But to do error handling, tiny little CLI change, or a tiny little library change. So this is back to our HTTP method. And we're just checking the response to that status code. If it's a bad request, we return a bad request error. If it's not found, we return proverb doesn't exist error. If it's an internal server error, there we go. The server ran into a problem, try again later. And again, that's it. That's all there is to it. And now we're allowed to force errors because we can handle the errors now. So in the CLI, we're checking for an error variable. If it's set to set to 400, then it sets a header. And if it's set to 500, it sets a header. And the server's set up so that when we pass in these headers, we can force errors because I don't want to sit here and wait for the server to fall apart or something while you're all watching me. But again, and this is how easy it is to add headers to your requests. Just headers.set, the header you want to set, and the value you want to set it to. Not a big deal. So now if we take a look, and we do, probably would have been easier to type at this point. There it is. Do one of those. And allow forcing errors. Awesome. So now if we do that prob standard lib, and it still works, hooray. Theory is better than clever. And if we say we want a 500 error, proverb server ran into a problem, try again later. So now we've got error handling in there. We can send back user messages. Right. Alright. But I mentioned a robust and varied ecosystem around building CLIs. So I want to show an example of that. First of all, before I get into that, is everyone following so far? Have I lost anyone? Is it annoying to watch me turn my back on you every 5 minutes?
I have another question. So
Yes.
it seems like you're kind of focused on taking an existing REST API and adapting it to a CLI?
Yes.
Is that like
That is
one of the primary use cases, or, I mean...
That is what I know best, but it
Okay.
is certainly not a requirement. Go can do things like manage your file system. It can do things like do DNS requests. It can, there's actually a CLI for generating CLI code. So like one of the frameworks that we'll be talking about has a command that you do Cobra in it, and it generates the code, like all of the boilerplate for it. So really, like, and we'll talk about, like, there are other different types of CLI stuff, like readline stuff, where it's like a REPL, where it's you modify text on screen, or like a BIM, and all of that works as well too. We've got tools for that. It's a low enough level language that you've got tools for everything. I just happen to know HTTP the best.
So what if you have a more specific implementation of a REST API, say leveraging something like a Swagger framework?
Okay.
Is that going to still adapt well to...
Yeah.
Okay.
And there are even Swagger libraries that'll help you kind of smooth that out easier. And I believe you can actually generate code using tools that Google is, that'll generate code for your API using Go.
Can you use Go to cheat at Pokemon Go?
I would imagine so,
It
but
seems
yeah.
like just linguistically.
right? Like it's, I don't know, but that's outside my area of expertise. True chainers don't cheat. It's really how I
I
feel
have
about
never
it.
done it, but
Um,
for practice.
Yes, it's a interesting computer science problem. You all know I'm on Windows, which comes to surprise later. It's okay. Promise I'm not a Windows developer. Not that there's anything wrong with being a Windows developer. I'm not good enough to set myself up for that. So yeah. So, any other questions? Sorry. Cover that. Awesome. So let's add a bit of color to our CLI example here. And what was that?
I said you spelled color wrong.
I did not spell color wrong. Y'all spell color wrong. But yeah, so this looks like a huge diff, right? 19,370 additions. Huge diff. It's because I vendor my dependencies. Don't worry about it. It just means all my dependencies are in the Git repo with what I have, so that even if somebody unpublishes a module or something, then I'm okay. Not a dig at Leopard,
It's like
but
you've been burned by NPM.
I haven't. I just had like a really good ops director who liked keeping his uptime. So he was like, yeah, no, I don't care if anyone unpublishes their Git repo or anything. Like, our shit will work. And it's okay. But yeah, so it's really intimidating at first, but then you realize that this is the only file I changed, and the rest of it's all dependencies. So this is the change that's required to add color. So I added this color library in here. I changed from printline to printf, so it's this formatting. This just says put this string over here in this position, same thing over here. And I defined a color up here that's red, and then I made a bold red, which is red that's bolded. And this is just how you turn text bold red. So now error will be printed bold and red if I did everything right. And it'll be printed from this. Everyone following?
Mm-hmm.
Cool. So now we're gonna go over here. We're going to git checkout standard 3. Add colors to arrow code. That's right. And install. And we'll do that. And we'll do so. Still works the same. Still returning aphorisms. Awesome. And let's give it a bad request error. And it's got color. Hooray, colors. I like colors. So again, that's just, I basically just reached out, modified my code by a couple lines, and the community already taken care of it for me so that colors work.
Slightly easier than Bash.
Actually done it by hand, and I was like, this seems silly. Let's see if somebody else has solved this. Sure enough, like 6 different packages. I'm like, oh, I feel bad about myself now. But of course, there are different kinds of command lines. Like, some want to use the command line flags. Some want to use subcommands like git add or docker build or stuff like that. So can you do subcommands? Of course you can do subcommands. I probably wouldn't bring it up if you couldn't. I would just hope you all didn't notice. And you are all thoroughly invested before you figured it out. So again, it's a small change. We're going to remove the flag package we imported that helped us parse flags. I'm doing a print usage function here so that people know how usage works. Oh, because that's the part I didn't actually show you. Oops. Let's do this here. There we go. Prov stand lib. Oh. It auto-generated a help message for me so that you know that you can pass in the proverb as a command line argument. Hooray! Anyway, so I removed the flag package. I now have to take care of the usage myself. That's sad. I've got to do stuff. And it's just going to print a message, and it's going to have usage in yellow. And I won't show you the whole message because it's really not that interesting, and we'll see it on the screen anyway. And then all of this is my subcommand stuff. And then I remove the flag stuff. So we'll walk through the subcommand stuff really quick. We're using this os.args variable. Os.args is just an array of all the arguments that are passed in, starting with the command name. So that's why I'm checking for 2 and 3 instead of 1 and 2. It's 0-based. So if I don't have enough, or if I have too many, then print the usage out, exit with error code 1. If I've got an action, which is a subcommand, that's going to be the first argument. And if I've got more than one argument, then the ID that I want to retrieve is going to be the second argument. So it's going to be like, proverbs get errors or whatever, proverbs get mutexes, something like that. If the action is get and I don't have an ID, I need to print usage because you don't know how to do this. If action is random and I've got an ID, I need to print usage because you did it wrong. If action is help, then we should print usage as well so people know what to do. And if action is not help, get, or random, then we should print usage because you did it wrong. Everyone follow so far? Cool. And I keep doing that no matter how many times. Alright, so let's get rid of our old. And we want to check out standard lib. What number are we on now? 4. Alright, we're using subcommands instead of flags, so that's right.
So will it not overwrite your binary there? You just recompile within your version?
I mean, it probably will. Let's actually find out next time,
Okay.
but I just wanted to
Be an extra function.
be clear and make sure everyone knows what's going on. So if I run it without, it's going to give me usage. There's my usage. If I ask for random, it's going to give me a random one. And if I ask for, let's go for errors again. Here's the errors message. Make sense so far? Alright, so we're moving along. I hope I have enough content here for an hour. I've actually given this talk before, so it's gonna be fun.
I want to ask another question there.
Yes.
So your print usage looked like a custom implementation that's just for one. What if you want to do context sensitive, like they put these 2 command words in and therefore give them a more specific command page?
I
Do you need
mean,
another custom implementation to do that, or?
I mean, you could do it custom. It's going to be a lot of code. It's just annoying. So we will get there, I promise. But there's more because we can use flags and subcommands. So, for example, here's one where we're adding a verbose mode so that you can get the ID. Like I keep passing in errors as the ID. How do you know what the ID is? So we can add a verbose mode. So we're going to add the flag package back in. We're going to add to I forget what I changed on that line, but it doesn't matter. And then the important part, and now it's going. I can't stop it. Okay. Oh, I added support flags message to the bottom. Okay. Flag.print defaults is just going to print what the flag message, like that flag help message we showed you before is. That just says here are the flags, here's what they mean, here's what you can do. So I'm adding a verbose variable that's a boolean. Again, I'm assigning the value of v to it. It's by default false. Its help message is going to be print the proverb's ID as well as the proverb. When I parse, it goes up into the verbose variable. And I'm setting flag.usage to print usage. And what that means is I'm overriding the function that's called when help is, the dash help is called. So that's again just an example. You can customize that as you want. And we've got to update, of course, our args because now that dash v is going to be in the arguments that are passed to the command line, right? So now there's a flag.args method that allows us to strip out all of the flag values from that argument list. So we're going to use that instead of the os.args. So we replace all of that. And then finally down at the bottom, the output is just going to be the proverb value. And if verbose is true, then we're going to prefix it with the proverb ID and a colon and a space. And then we're going to print it out. Everyone follow? Cool. Have I lost you yet? I'm more worried about losing interest than I am about you're a bright bunch. I'm not doubting you, I promise. So that's awesome. So let's do get checkout, and we're on 5 now. 5. Use subcommands. Add verbose mode. Awesome. So now we'll do that. Go install. And we will do prov stand lib, and we're going to do dash help just to show that off. So again, that allows us to see that. And we do it without this. There we go. Now we get support of the flags as well. And if we do prov stand lib v random, then it's going to tell us that ID is go fumped. If we do it again, unsafe. If we do v get go fumped, it's going to continuously return that one for us. So that's again how we can use subcommands and flags together. Got it so far? Awesome. And we will go back here. Alright, so static compilation is great, but anyone that's written C or has written, you know, C++ knows that's going to become a pain when it comes time to run it on anything other than Linux, essentially. Anything that your build server's not using. So there's probably a Windows pun I can make here, and now you'll understand why I'm running on Windows today. But one quick change, and the quick change is actually for the color of text, because Windows doesn't respond to ANSI codes like Unix does. So what we do to that is the library actually has a color.output. fprint is just printf, but the first argument is where you want to write the text to. Color.output is a colorized version of the standard out that is colorized across all different operating systems, Unix, OS X, and Windows. So we do that, we just update that wherever we're printing. And we can do, just check, that is standard lib 6, okay. Install. Scanlib. It's still gonna show us the stuff. Cool. If we do random, it still works. If we do random verbose mode, that still works. And now we're gonna do something a little bit different. We're going to build it for Windows. And this is the part where I pray that the demo gods are nice to me today, because I feel severely underprepared for this, and we're doing a live demo, and it relies on internet, and nothing can possibly go wrong. This is probably fine. And if you look, we've now got prov stanlib.exe, and we can move that to the slides. I need to do that with sudo make me a sandwich. And we can now go to I'm typing things and you can't see it, and that's okay, and I can't see it, and this is probably fine. And it didn't actually type. This is why I need to be able to say things. So I'm going to go ahead and download that binary right now. And it is downloading. Not commonly downloaded, it could be dangerous. Don't worry, I don't think it's dangerous. I'll find out in a minute, 'cause I'm about to run it. So I already set the environment variable, 'cause setting environment variables is weird in Windows. But we're going to go ahead and run that, and you'll notice I've got usage there. The usage text is in fact yellow, even though we're on Windows. We can do view random, and I'm getting values. And again, just download the binary and run it. Hooray, it worked.
So
Yes.
I wasn't gonna bring up Windows CLI, but since you did, like, the standard way to do that on Windows would be to make a PowerShell module.
Okay.
Well, a lot of people would, because at least in server environments and even in desktop environments, you have PowerShell. Is there an easy way to port your Go code into a PowerShell module for a CLI?
I have no idea what a PowerShell module is, so I can't actually tell you that. This is actually the first time I've ever run a Go binary on Windows. And I actually had to figure out how to run an exe and then command line. So, no, I'm sorry, I did this last night at 3 a.m. to make sure this worked. But this demonstration is the only time.
I was gonna say that was riding, the
That was
demo right on the edge there.
I mean,
Yeah, that's great. It worked well.
I like risk. I also like not being ashamed of myself in public. So
That's great.
Having done quite a bit of Windows stuff in the past 6 months, this is impressive. So,
well, thank you. But again, just executable. If the PowerShell can run any executable, then it can run this.
Yeah, so PowerShell is the command line replacement that Microsoft is putting out for
Okay.
just standard command prompt stuff.
Uh-huh.
And usually for admin tools, you can run a command that downloads a module from a repository and then gives you the commands so that, but
It
this
kind of
will
takes
work as
care of
well,
those,
yeah.
environment variables and like the path and stuff.
Don't
Okay.
they have like Bash in Windows now too or something?
Yeah.
Yeah.
The bash, if you compile Go binaries for Linux, they work in bash. Just like
Bash for Linux.
all the other stuff. It works on OS X.
And Windows SQL Server for Linux. It's getting weird.
Yeah, everything's weird. Operating systems are weird. You can actually run the binaries without an operating system if they're statically compiled. So for Docker, for example, when we deployed Go apps in Docker, we would do them in the Scratch Docker containers. So we would have 10 megabyte containers that would run our web server for production traffic. So that was cool because there was no operating system to it. Yeah. So that is Windows. And yeah, I'm running this in Chrome's SSH app thing, so that I can run on Windows, but not do an entire talk in Windows, because that would suck. Again, I'm not a Windows person. I don't have anything against Windows people. I just don't know what I'm doing with it. So this is the first Windows machine I've owned in 4 years. Yeah, so simple deployment across multiple operating systems. You can build for any system from one system. So whether you're on Linux, Mac, Windows, you can build for Linux, Mac, Windows. Not a problem. But I can see a problem already. I don't like code like this. Because I'm like, okay, so now I want to add another action. I can see this working out real well for me. So this is an issue for me. How am I doing on time? I'm going to check my phone in the middle of the talk. That's not bad at all, right? 12:41. All right. So I got a little bit of time here. So let's talk a little bit about non-trivial CLIs, because not everything can be a simple GET request to an API server, right? With one action. It's going to become a mess to handle it. And again, that whole robust and varied ecosystem thing comes into play again. It's helping me out here, making my job simple. There's a very popular one called Cobra. And Cobra is an incredibly well thought out framework for CLI development. It's in use by popular tools you probably already use: Kubernetes, Rocket, etcd, parse their command line for their API is built in Cobra. And it's already got a handy CLI for bootstrapping quickly. What I'm about to show you actually comes from their CLI. I bootstrapped quickly using their CLI and then changed like little chunks of code and called it a day. But the basic idea is you define what your command is, then you register subcommands of your command. You register flags on those commands or subcommands, and you can register them locally or persistently. And there's a weird distinction there. So you can, a local flag registers only on that command or subcommand. So if at the top level you register a flag and it's locally registered, then none of the subcommands will accept that flag, but the top level command will. Does everyone follow so far? So if you do git add, -- version, it's going to return a usage message. But if you do git -- version, it's going to return version. Make sense? Persistently, it cascades to all subcommands. So verbose, for example, you could add on git, and then git add would also have a verbose flag, and then git add child would also have a verbose. It follows down. Everyone following so far? Did I do an okay job explaining that? Awesome. And of course, you can accept arguments. So commands do things, args are things, and flags modify the commands. Everyone follow that distinction? The commands are like, another way of saying it, the commands are the verbs, the args are the nouns, and the flags are the adjectives. I was an English major, so that makes a lot of sense to me. I'm like, now we're talking my language. So commands and subcommands are just functions in this world. So that's actually a really helpful way to break it down. And it takes care of all of the help and usage info for you. And we'll actually get back to your point about can you display just the usage info for a subcommand instead of the entire command. So I actually ported our simple application to Cobra. This is all of the code for it. We start out with the main.go file, and this is the kind of the entry point. This is going to be what's run when the executable is run, and it's the best file ever. It's literally just import this package up here, this command package, and execute it. That's it. And so let's go look at the command package. Okay. I know I'm tempting the demo guides, and I'm using network, so this is going to be the best. And surprisingly, everything's worked out actually okay. So, fingers crossed, jinxing it. So yeah, so let's start at the root. The root is going to be the main command. It's what they call the root command. We're defining a verbose flag. We're doing that print bold red color thing again. And we're defining a root command. So here's where the Cobra specific stuff starts. And it's defining a Cobra command. And this is going to be the use for it. So this is going to be the command name. So if it's so this would be get. For subcommand, it would be add. A short description, what it does.
Would you move it up on the screen so people can see what we're doing?
Oh, I'm sorry. My head is in the way. There you go. Better?
Yeah.
Awesome. Alright, so yeah, you've got the name for it. This would be like get or add for subcommand. Short is just a short description of what the command or subcommand does. Long is a longer description, obviously. And I'm using the silence errors and silence usage. Cobra comes with its automatic built-in error and usage handling for you. I didn't like the way they were doing return codes, so I wanted to specify my own return code, so I told them not to do anything when you have errors. I'll take care of it myself. And they're like, okay, that's fine, and we'll get to that code. And so execute adds all the child commands to the root commands, sets the flags appropriately, and is what's called by main.main. So when we called command.execute, this is what we were calling. And you're going to notice the pattern here. Now we're just calling root command.execute, and that's this up here. And that's going to call, that's just going to print usage. So we can associate code with it. I chose not to associate code with it. So like a get, it doesn't do anything when called by itself. But I also return an error from it if the error is that we're missing an ID, which I'll show you in a second, then print the usage for it. Otherwise, print out the error message itself using the red bold error. And finally, exit 1 if there's an error. Otherwise, it's just going to return with 0. Everyone following? Cool. The only other thing we need is this init function down here, which is where I set the persistent flag. Persistent flag, again, is going to cascade, so this verbose flag that I'm defining here can be used on any of the subcommands as well. We're going to store the value in the verbose. Verbose is the long flag, V is the short flag, so you can do --verbose or -v. Both work fine. Defaults to false, and here's the usage information for the command. Everyone following? Sorry, is my head in the way again?
Could you scroll up a little bit?
Yes.
Where is the error defined or passed into the execution, the ERR? Or that just gets set by Go if, is that like a standard reserved?
Oh, so I'm sorry. I did not explain this. So root command.execute returns an error.
Oh, okay.
An error type. An ERR gets set to the error type.
The error it's the return is set to that. Okay.
Yes, but in Go, errors are just values. We don't use exceptions. We don't use it. It's an error-based language, and the error is usually returned. So it's just a value. We can pass that variable around. I can.
It's not a fundamental type like in
so
a primitive.
now we're getting really deep into the language, but error is it's a primitive type, but it's an interface, and it's anything that has a .error method that returns a string.
Okay.
So
So
now
the
we're
value
getting
you're
into
passing around is a string though, not.
it's anything that has a .error. Now we're getting really into the Go's
Sorry.
interfaces. No, you're all right. It's anything that I can call error.error on. So you see how I'm calling error.error on?
Yeah.
Are you familiar with Java's interfaces?
Mhm.
So this is like a Java interface, if you think
Okay.
about it that way.
Yeah.
Does that make sense?
Yeah, yeah.
Okay. All that's guaranteed about it is that I can call this error method on it.
Right. There's a guaranteed implementation there, but not.
Yeah.
Okay.
So otherwise, I'd get a compile time error that says that's not an error you're trying to return. Make sense? And we're actually going to get to where I'm defining that error. So that's the root command. Let's actually look at one of the subcommands. Let's see here. We're going to go with get that go. So this is how you retrieve a single one. And again, we're going to specify the usage here. So that's get, and it shows that you need to pass an ID to it. You retrieve a proverb specified by ID. And here's actually the fun part. So we're using this run E. So there's two different things you can specify, run and run E. Run E returns an error, run does not. Simple enough. And it's a function that accepts a Cobra command and arguments and returns an error. If there's not an argument for it, you return error missing ID. An error missing ID is an error defined up here that just says ID must be specified. Then we call get proverb, which I'll show you in a second. It's just some helper code around it. If there's an error, return the error. Otherwise, print it out. This is all pretty much the same from our snare lib implementation. And finally, the only important part in it, you've got to add this to the root command. So you register with the root command. So the locus of control is the subcommands add themselves to the root command. Other libraries have the root command specifies subcommands. Does that make sense? Awesome. All right. It's hard to explain in my head, so I'm glad that y'all are following me, because I don't know how else to say it.
You do that if you're adding a subcommand to another subcommand, you would still do that
Yep.
same dot. Okay.
Yep, you just add it to the subcommand, not root command. So
Not
you
root
would do like get command dot add
And
command.
root command exists and is defined by the Cobra library, or did you have to instantiate an instance of it?
Nope, that's this right over here that it's just this container over here. Here's root command right
Okay,
there.
you did define it.
Yep.
Okay.
And all of this is kind of scaffolded for me by the CLI, but yeah. So I was basically just filling in the blanks, but this took me like 15 minutes to make. So yeah, that root command is that same variable. So that does not work. Okay, here's the code that I kind of pulled out into a helper. This get proverb code passes an ID. It can be empty, but it checks for the environment variable, adds the header, takes care of errors. It's all of that stuff from the standard lib implementation. But because we've got two different subcommands now and we can't reuse the same code, I pulled it out into its own method to kind of make it easier. Everyone following what just happened there? Awesome. And yeah, and then random looks a lot like get, except it doesn't have the
I'll
ID.
ask one more command or question there on the errors.
Yes.
If you want to define for a whole class, like you're using the HTTP error codes 400, 500, if you wanted to do 4** or 4.x, is there a way to do that in Go so that you don't have to manually go through, I know 500 through 599 are server errors and I just want to return one generic thing. I don't care if it's a 500 or a 501 or a 505.
Yeah, you can do if response.status code is greater than or equal to 500 and response.status code less than equal to 599,
Okay.
then return server error, basically. Does that make sense?
Yeah.
So we haven't even got to the Viper integration. There's also a library called Viper that manages configuration for you. I didn't get into it personally because I've never used it. It was late and I didn't think y'all were that interested in it. So check it out, basically is what that means. Oh, and we can actually...
Can you say that again?
So Cobra there's a package called Viper, written by the same guy that wrote Cobra. Viper manages configuration, so it does things like configuration files, environment variables, flags, all of that stuff.
Okay.
Cobra integrates really well with Viper. I didn't include Viper here because it was late and it was going to be more code and I didn't really understand Viper really well, so I glanced at it for like 3 seconds and didn't understand it, so I was like, I'm not gonna try and show people that. But did I answer your question? Awesome. So I promise this will be the last time I force code on you, but so we can go now to the proud Cobra, and again that's just that stuff I was just showing you in GitHub, and we can now call proud Cobra. There's our usage stuff. There's the long description of what the command does. We can do prov Cobra random. How to return that? We can do random v. We can do v random. We can do get, and there's the get specific usage we were talking about.
Nice.
So it kind of takes care of a lot of that for you, and not with a billion if statements counting the number of arguments you have, which I'm a fan of not doing. And we can get errors, and that works as well. So yeah, so that's Cobra. If that feels over-engineered, if that feels like a lot of code and a lot of boilerplate, you don't want to think of it hard, there are options for you too. DaCop is a README-driven CLI generator. And what I mean by that is you write the help message you want the user to see, and then it parses out flags for that and puts it all in variables for you. And they've got a Go library. So take a look at that. Like, so there's the message, like the usage, the options, and you just call parse on it. And you print the arguments, and let's see, it'll show us. I thought it would show us somewhere, but yeah, so it just prints out the values that you pass in. Does that make sense? Awesome. I didn't do an example of that one because I ran out of time, and I'm glad that I didn't because I got 5 minutes left. I need even more control over how information is displayed. Mitchell Hashimoto's library is probably going to be right for you. I'm mentioning this one largely because he's going to be my boss in a week. But also it's really great. They stubbed out the standard out, so it's now an interface. So now you can stub in, like, they've got a color standard out that manages so you don't have to do that weird color.print sprint func or whatever. You can do a mock standard out so that you can, for testing, print the standard out and then check what was printed. You've got a bunch of different stuff there. You can really fine tune and control what standard out looks like. And you need to really precisely control user input. Previous to this, I've actually written a lexer and parser in Go. They're incredibly fast, both in execution times and in terms of writing. It took me like an afternoon to write a lexer and parser that had its own specific grammar for what a command and subcommand and flag and argument look like. If for some reason all of the options available to you don't work, that's also an option. I'm not going to show you that because that's some talk in itself. You want your own REPL like CLI, like Vim or like Python's idle. There's the readline library for you, which is based on the new readline library. And I'm just going to show a video somebody else made here because I'm lazy. Let's see here. And this is just a terminal. That is very small. There we go. That is better. But yeah, so you can log in, it'll ask for your password, you can hide the password, you can, I think it's going to change the prompt now. Oh, no, it's going to list files now, and you can tab between files. But that's all within a Go prompt. So now they're going to run it again, and I think they're going to change the prompt. Yeah, they're going to set the prompt to something else. It takes them like 30 seconds. Let's see here. Hopefully not running over on time. I've still got 4 minutes. Alright. This actually worked out really well for a talk that I haven't practiced that much in terms of time. Especially with questions. Like, we're doing solid here. This is great. But yeah, so they send the prompt. You can enter passwords. You can change text when it's already been displayed. All that good stuff. So readline style library. That's also, if that's something you need, we can also support that. You got a lot of choices. Is basically what I'm trying to get across here. There's libraries out there for pretty much everything. A former coworker of mine wrote an entire terminal, like Bash or Z Shell or whatever, wrote it in Go. So that's like, you can do a lot of stuff. So we're gonna recap. I'm at the end here. I think I'm losing, I think you all are losing patience with me. So we're gonna recap really quickly, and then we're gonna be done, and y'all can ask questions if you want. Deploying interpret applications into uncontrolled environments is asking for a world of hurt. If I've convinced you of nothing else today, I hope I've convinced you of that. It's terrible. Please don't do it to me. You're not the only one that hurts. So it's a world of hurt because, you know, your business loses money. You get customer support requests. People are like, why are you bad at this? But you're not the only one that hurts. Like, as a user, I lose like probably days of my life at this point to try and figure out how to run interpreted applications on my laptop. Please don't make me do it. Go makes it really simple to generate static binaries for a variety of operating systems, and you can just download it and run it. So we get back to that, just download it and run it, and I love that workflow. There are more well-known ways to write a CLI in Go than I had time to code samples for. So like, we passed through like 4 in the last 5 minutes that I just didn't have time to code samples for. Those are all libraries that power large, well-known projects that you know today. I passed over probably 20 different libraries that I couldn't point to be like, oh, everybody's going to know what that is. So there are a lot of different ways to do this. A CLI for an API can be written in a trivial amount of code. I think I showed you the standard lib. It was like 80 lines long for a CLI GET requests to a server. So I guess the only question left is, what are you waiting for? Why aren't you writing your CLIs in Go yet? Why am I sad? And that's unless y'all have any questions, because that's all I was planning on talking about today. Cool. Does anyone have any questions?
Other than CLIs, what do you like to write in Go? Like what type of applications, and what type of applications do you not like to write in Go?
So my last job, I didn't actually write any CLIs in Go. I wrote web servers. All the web servers that I write are in Go because I think it's a really nice web language. I like doing CLIs obviously in Go. Honestly, like a bunch of my one-off data parsing commands and stuff are written in Go just because it's the language I know. I'm not sure it's necessarily best for it, but it works really well for me, and it's also quick. I've parsed like billions of log lines to try and generate like a load test profile so that I can run load tests in Go, and it actually didn't take me that long. But yeah, what I don't like writing in Go, you're gonna have a really bad time if you try and write a GUI. Like there's no other way to put it. It's just you're not gonna have fun. I'm trying to think what else do I not like. If you want like a web framework like Ruby or Django, you're gonna have a bad time in Go. It's just gonna make things harder than it needs to be with the static type. So it's like a strict type language, and that's just going to make your life miserable doing that. So I've tried that before. Don't do that. Just make an API and use a front end for the API. Answer the question.
So one thing that we use, like one of the main things we use CLIs for in our office is like maintaining our dev environments.
Yes.
And that's an enormously painful process. Like if one of us is working on another project and we have to switch back to something that's changed in a while, like it can be like several hours to get the project back up and running. So are there ways, have you done much work in terms of using Go or using your own CLIs to help make the developer experience on interpreted languages better? Or is that even something that would be possible?
I mean, I haven't personally. My stance on interpreted languages is it's fine if other people want to write them, but please don't make me write them. But I will say Mitchell Hashimoto, which is the guy that whose CLI library we were just talking about, who's going to be my boss in a week. He wrote Vagrant, and Go is the language of choice at HashiCorp, which is the company he started. Docker is written in Go. Most of the developer tooling around managing environments is written in Go at this point, so I can't imagine you would have much problem with it. It would just depend on what you need to do to manage your environment. If you need to move files or set environment variables, setting environment variables is going to be tricky. Moving files around should be fine. Setting environment variables, I imagine you would set the environment variable and then proxy, like start the command yourself through the Go program, and that's going to be fine. Like I've done that before. That's not a big deal.
A lot
But
of our problems though come because of dependencies change.
Exactly.
We haven't updated toolings because of the new dependencies.
Exactly.
And the changes. And it has nothing to do with being an interpreted or non-interpreted language.
Right. I just wonder about kind of having some of our wildland dev environment tooling that could kind of take care of some of those dependency changes for us and like do some of the heavy lifting there to make sure that like the versions that you had installed were the right ones, you know, for the project that you're switching to, that kind of thing. I don't know. This is just it rang true in terms of like getting, you know, switching environments or switching projects and having your environments change is kind of the pain point for me on this stuff.
I will say, when it comes to dependencies, other than deploying, like when you're managing dependencies on a developer, it keeps happening to me. When you're managing dependencies on a developer laptop or a developer machine, Go is going to quietly stand in the corner and whistle and not throw stones at other languages, because it's something that we're still really trying to get really good at. We don't have an official solution yet, and it's on the brink of being there, but it's not quite there yet. Yeah, so that partially comes out of the language developed at Google, and they just have a mono repo, so they're like, yeah, everything's fine. And everyone's like, no, everything's not fine.
They control the repos pretty well, and the open source community is going to not do that so excellent.
Yeah. So that's something that is still improving. I personally have developed applications in production that I've maintained over the course of years that use open source libraries that have been fine, but I don't want to say, oh, you're going to be fine just because I've been fine.
Well,
Does that
sure.
make sense?
It probably goes. It probably depends on your trust level with the open source library.
Right. Or like
and that's-
you saw I vendored all of my dependencies in, so I was just like, yeah, it's fine. You can do whatever you want with your code now because I've got